Hey, hey, hey. Hey, hey, how to build a utility test. So previously we talked about what features you're going to build in your utility test. Now we're going to talk about how to actually build it. And the crux of this chapter and this exercise comes from something I'll tell you about after this slide. So problems it solves. Problems we're going to solve for you with this exercise. What if you don't have a development team? Like what if you're not a developer yourself, you don't have access to a team, you don't have money to pay them, all that kind of good stuff. We're going to answer that question. And number two, we're going to help you come up with the most effective way to get product feedback. The fastest way to get the feedback, fastest way to respond to that feedback, basically the fastest way to know if you're solving the problem. Now, as I was saying, the crux of this chapter really can be summarized by a quote from a guy named Paul Graham. Paul Graham is the founder of Y Combinator, by far the most successful and most famous accelerator, startup accelerator. And he's got this quote that I love, and it really applies to utility testing. And the quote is, "Do things that don't scale." When you're starting off, do things that don't scale. So don't worry about scale when you're first starting. So let's talk about why that is. Now, your temptation, the natural temptation for all of us, is to want to emulate success. So we see these big successful companies all around us. We are customers of theirs. We read about them, and so we want to emulate them. We want to do the things that they're doing. So we want to build something that looks like successful companies. That's our nature. Like, oh, Amazon's doing this thing, or Facebook's doing this thing, or this other app is really successful. I want to be and look like them. That's natural and makes sense. So successful companies, oftentimes they'll have tons of customers, which is obviously something that you probably want. They'll have a global presence. They'll be available to multiple customer types and multiple customer segments around the world, different time zones, all that good stuff. They'll have beautiful design. They will look really great and really aesthetically pleasing. They'll have instant response time, so they'll be interacting with their customers instantly, and they'll, provide updates on a crazy frequent basis, and they'll do all this amazing stuff. Plus, they'll have scalable technology, so they'll be able to build amazing technology that can scale both in terms of supporting a huge number of customers, but also tons of data, doing everything in real time, all this kind of good stuff. So that's what successful companies look like. But it turns out your customers don't care about those things. When you're first starting, your customers don't care about any of those things. They don't care about how many customers you actually have. They don't care about your global presence. They don't care about your beautiful design, whether your response time is instantaneous or not, whether you have a huge support team. And they certainly don't care at all about scalable technology. The only thing your customers care about is solving their problem. They don't care about all that extra stuff. They only care about solving their problem. So you only need to go and create those things. You only need to worry about response time, and you only need to worry about design and all that good stuff to the extent that it helps solve their problem. So they only care about solving their problem, which is what you care about. You only care about solving your customers' problems. So, and the other thing to keep in mind, that's number one. Number one point is customers don't care about you looking like a successful company. They only care about you solving their problem. The second thing that you want to know, keep in mind, is successful companies don't look successful when they're starting. That's one of the keys of a successful company. No great, awesome, successful company, or very few I can say, come out of the blocks and launch looking like they do when they are successful. That's because it's too resource intensive to look successful from the beginning. It costs too much money, and it often leads to failure. So if we take a look back at a couple famous examples, the Google search actually starts by providing indexing for Stanford searches and Linux searches. Yeah, so it doesn't try and boil the ocean. It doesn't try and do everything amazing. It doesn't try and do the whole web. It starts with two searches, Stanford and Linux, and then from there they build. Facebook does the same thing. Facebook doesn't start by trying to boil the ocean and provide, events and photo sharing and advertising and all that kind of stuff. They start by connecting people, and a very, very small group of people, students at Harvard University. That's it. Yeah. So they don't look great. They certainly don't try and meet everyone's needs. They are very, very small and very minimal. So you want to remember that the people that you want to emulate, they didn't look like this. They didn't look like the companies that you're seeing right now. They look like your company's going to look when they started. All right, so combining these two ideas, combining the fact that we want to do things that don't scale with only solving our customers' problems, taking those two things and combining them, the solutions that we want to build and the things we want to utility test become pretty obvious. Things that don't scale and that only solve our customers' problems are manual solutions to problems. And that's what I'm gonna encourage you to do, is build your manual solution to a problem, and that's what you want to test. And here's why. Manual solutions are incredibly fast to build because there's nothing to build at all. It's you doing the work. You go out and you solve the problem yourself. So there's no build time, there's no launch time, there's no any of that. It's crazy fast because you're basically going to do it yourself. So instantaneous functionality. 2, it's way faster for you to get feedback, because not only because you're going and presenting a solution to your customers, if you're doing it manually, you are naturally interacting with your customer. So you will have every opportunity to hear what's working, what's not working, as opposed to an automated solution where you have to actually build in feedback mechanisms. When you're doing it manually yourself, you'll be able to hear the feedback directly from your customer. It's also faster to implement your feedback. So if you're hearing instructions, you're hearing, oh, you know what, this is working, this isn't working, you'll be able to make the change instantly to the solution you're providing, as opposed to trying to take the feedback you're getting and then go and change automated solution and then go relaunch that and put that back into customers' hands. It will be instantaneous turnaround on the feedback. It's also less costly to build. Not only is it faster, you don't have to pay anything for it, or you'll pay very little for it. So there's no development team to pay, there's no servers to pay, there's none of that design work to do. You're just going to do it all yourself. You're going to do it all manually for far less cost than you would otherwise. And you don't have to write any code. So if you're not a developer and you don't have a developer team, you don't have to write any code. For this phase, we're not going to worry about code at all. Side note, for those of you who are developers, like me, this is where we can kind of get into trouble. And the reason is it's so fun and it's so tempting to build an automated solution to a problem that sometimes we can justify, like, hey, you know what? It'll be faster for me to build an automated solution to this problem than to do it manually anyway. So why don't I go just do that? That may be true, but it is probably not true. It is probably faster for you to go and do this manually, even though it might not be as fun. And the reason is that you will likely spend more time than you think writing software, because if you're a developer, you know it often takes longer than we think to write software. But you will also end up becoming emotionally attached to that software. It'll be harder for you to change or throw it away. And all of these things about getting feedback and implementing feedback are also still hold true. So if you can let yourself go and leave your coding skills for later, and we'll talk about when those come in, you will be better off doing your solution manually first. All right, so let's talk about an example. Zappos is a fantastic example of this. Zappos, the online shoe store and now apparel store, hugely successful, and they don't start by launching a full website where you can order stuff, and they've got like a factory behind the scenes and shipping. They start by taking pictures of shoes in an existing shoe store, posting them online, and then if someone buys the shoes, they manually go down and they buy the shoes and send them off themselves. Yeah? So this is the manual solution to the problem. So this is what we want to replicate. This is what we want you to do, is to sort of manually replicate what the automated solution could look like once you've worked all the kinks out. Okay, so building, I want you to think of building software, or creating any potential solution. Building software in particular, though, is like building a robot. So robots are great. for a number of reasons. Robots are scalable. You build it once, you can replicate it multiple times. They're less expensive than humans. Once you've built it, they can work 24 hours a day. They don't need food, any of that good stuff, and they make fewer mistakes than humans. So that's the reason why robots and automated solutions are great in general. The problem is, they're also great to scale a solution once you've found a solution. So a robot is something that you build once you know how to do something and you just want to repeat the process ad nauseum. That's when you put a robot into play. That's when you're going to put your software into play. All right. Robots suck for the following reasons. Number one, they're super expensive to build. Think about trying to build any sort of robot. Like, there's so much time and energy spent on building the robot that you don't have time to actually understand how you want to solve the problem. So they're super expensive to build. They're crazy expensive to change. If you got something wrong, you have to go and change it. And they're horrible at finding the ideal solution to a problem. A robot just does one thing over and over again. That's what they're sort of designed to do. What we're actually looking for is we're on a search for the best potential solution. So what's going to provide the most utility. And so now is not the time to automate anything. Another example, just sort of to think about, drive this concept home. Imagine I wanted you to build me a way to be awesome on Twitter, a way for me to be awesome on Twitter. So, build me some tool, build me some solution, build me something that's going to, automatically interact on my behalf on Twitter in a way that's valuable to everybody. So, would your first step be to go and build a robot to make me awesome on Twitter? Of course not. Your first step would be to manually figure out, well, how does one become awesome on Twitter? Like, what are the right interactions to provide on Twitter to create a great community? To try and build the robot simultaneously while also trying to figure out how to be awesome on Twitter is asinine. So we don't want you doing the same thing. We want you to manually figure out how to solve the problem, and then you basically write the software to help eliminate you from the process, to help eliminate the manual steps, and you start automating, and then you start scaling. So while you're still searching for the solution, keep it manual. Once you figure it out, then you apply software. So just a couple quick notes. Other words for this or terms for this in the lean vernacular: a concierge MVP. So the term concierge MVP, if you've heard this, what that basically means, that's exactly what we're doing now. Concierge MVP is where you're actually telling the customer, hey, I'm going to do this for you manually. I'm going to walk through this, just like a concierge would at a hotel. They were going to manually help you solve a problem. Another term, Wizard of Oz. This is where you give the illusion that a software or piece of technology is solving the problem, but behind the scenes it's just a manual transaction that's happening, or manual labor that's going on. The Zappos example is an example of Wizard of Oz, where it looks like there's a website that's doing all this amazing stuff, but really behind the scenes, as soon as you click the order button, it's a person who goes down and buys the shoes and then mails them to you. So if you're either one of those terms, that's what we're doing here. We're just calling it a manual utility test, and you can choose whether or not you tell the customer you're doing it, or whether or not you're just doing it behind the scenes. So for utility testing, remember that you don't want to build a robot. Now is not the time for building a robot. You want to solve the problem manually first, and then we'll go build your robot. So just to recap, manual solutions are faster to build, faster to get feedback, faster to implement the feedback, less costly to build, and don't require any code. All right, so let's start off by figuring out, let's continue by figuring out what exactly your manual solution is going to look like. So you'll start with the utility testing feature list that you created from our last exercise, and you're going to take these 3 versions from your step 4 here, and you're going to fill them out in building your utility test worksheet for the V1, V2, V3 feature list. So go ahead and fill those out. So these are just the features. And now we're going to give you 2 opportunities to fill in potential solutions. The first is, what does the scalable version of this look like? What does it look like once you automate it? Now, your answers here don't have to be right. And in fact, if you can't even come up with one, that's just fine too. But what this step enables you to do is to clearly differentiate between scalable and manual, so that you can take your cool, awesome visions for amazing scalable solutions and write them down and have a place to sort of think about and work on them eventually, but then contrast those with your manual solutions. So in this case, my first feature is step-by-step exercises to help people walk through finding their product market fit. So a scalable version of that are workbooks, right? So this is a workbook where I can, just like you're filling out now, it's scalable. I can take these exercises, I can put them together, I can make them available, and people can leverage them, download them, and use them on their own. If I wanted to provide accountability, a scalable version of that are virtual peer groups where I connect founders with other founders and they help each other, hold each other accountable. So that's a scalable way where I'm not it's not requiring my time necessarily, but founders kind of hold each other accountable. And then encouragement. So a way to help people keep their own motivation, I could do provide like gamification for completing exercises, so rewards along those lines, and or community support. If there's a community and the community sort of gave encouragement to a founder as they were going through the process, that's a way that I could go do that. So these are all scalable ways to do this, ways that don't require my manual intervention, and these are all robotic ways. These are all robots, things that I can do sort of eliminate me from the process. So if that's eventually where I might be able to go, what are the manual versions of that? And that's step 3 here. So step 3, you're going to think about what can I do manually to try and solve these problems to make sure they actually do solve the problem before I invest in building the scalable version. So the workbook version of manual solution, I can simply work with mentors one-on-one. I can take mentors, founders. I can take founders, people who read my blog, and I can have them contact me, and I can work with them one-on-one and actually walk through these exercises with them. I can do the same thing at workshops, and that's actually where all of these things come from. They come from real experiences working with founders one-on-one, and by and large, these exercises have been used with founders to help validate that they actually work. So that's the manual version. Accountability, what does that look like? Well, I could actually set up bi-weekly calls with founders, so I don't necessarily have to, my first version, I don't have to have other founders provide accountability. I can provide the accountability and just set up regular meetings with them to check in and see how things are going and make sure that they're doing what they say they're going to do. And then finally, encouragement. Well, I can manually send emails to people to check in on how they're doing, congratulate them on things that that they've accomplished. So I can replicate all of this manually to see if it actually generates the metrics that I'm looking for. So that's what you do. All you do is figure out your feature list and figure out the scalable version and then the manual version of those things. And now you know what to build for your utility test. Alright, so once you validated the manual solution, then you will automate it during the scaling phase. So scaling phase is there's a whole phase about scaling, and it comes next. So that's the next workbook. So we don't worry about scaling now, that will come later. Alright, so the problems that we've solved, we've helped answer the question, what do you do if you don't have a dev team? Well, it turns out you don't need one. In fact, you don't even want one right now. Secondly, the most effective way to get product feedback is to get a solution to your customers ASAP, and the fastest way to do that is by doing a manual solution. Of course, the fastest way to respond, react, and implement that feedback is also to have a manual solution. So manual solution is going to be the most effective way to get your product feedback and find the right solution for your customers. Alright, so next up, we're going to figure out what do you measure during your utility test to know if you're solving the problem in the best way possible. Alright, this has been How to Build a Utility Test.